Hi everybody, today we will be talking about the binary star systems, meaning that there are two stars and they are rotating around the center of mass. We know the masses of each star individually, which is small m and big M, and we know the distance between the stars. And the question is, what will be the period of rotation of the stars? Like what time will it take for the stars to do one whole revolution? Okay? So first we need to find the distance from this star to the center of mass. Then we will use the Newton's second law and the universal gravitational law and we will get the final result. Okay? But first, what is the distance from this star to the center of mass? Because they will be moving on circular trajectories around the center of mass. Let's write the definition of center of mass. It is that small m times R1, it should be the mass of the other star times R2. And also let's use the fact that R1 plus R2 will be R. So R1 plus R2 is the distance between the stars. From the upper parts we get R2, which will be this part divided by the big M, which will be m times R1 divided by big M. And let's plug this there, and we get R1 plus m R1 over m should be R. Let's take R1 out of the brackets, and what do we get? R1, 1 plus m over m should be the distance between the stars. Let's simplify it one more time, and we will get R1 m plus m over m is R, and we get the final result. Let's write it there. That R1 will be m times R over the sum of the masses. It's an interesting result, and the result is that the distance from one star to the center of mass is the mass of the other star times the whole distance divided by the sum of the distances. Sum of the masses, this one. Okay, now we know R1, and now we can use the Newton's second law and the universal gravitational law to find the period of rotation, the time it takes for the stars to do one whole revolution. Okay, so the universal gravitational law tells us that the force on this and this will be Gmm over R squared, where G is the gravitational constant. This is gravitational constant. Gravitational constant. It's a constant in the whole universe, and it is 6.67 times 10 to the minus 11 newtons meter squared over kilogram squared. It is the constant in the whole universe. And the universal gravitational law tells us that the force between the stars will be the gravitational constant times the masses, Gmm, divided by the total distance squared, R squared. And it should be mass times acceleration. So let's write on this one. It will be mass times centripetal acceleration, because it is moving on the circle. But what is the centripetal acceleration? The centripetal acceleration is omega squared times R. Omega squared times R1, where omega is the angular velocity. This is angular velocity. And it is related to the period as this. Omega is 2 pi over period, okay? 2 pi over t. Angular velocity is 2 pi divided by the period of rotation. That is what we're looking for, okay? And there is R1 because it is moving on the circle which has the radius R1. So let's simplify this. Maybe I can delete this down part to get the final result, okay? Let's simplify this. So we get that Gmm divided by R squared will be the mass times omega squared. Omega squared will be 4 pi squared over period squared. This is omega squared times R1. And R1 is the big M times the radius divided by the sum of the masses. Now, the masses cancel, and what will be t squared? T squared will be these coefficients multiplied, which is 4 pi squared r cubed divided by g n plus n. To find t squared, we multiply these coefficients and divide by the other coefficients. And what will be the final result? The final result is we have to take the square root out of both sides. From 4 pi squared, 2 pi will come out. In the square root, we will have r cubed divided by g n plus n. This is the final result. So, to sum up, if we have two stars, and we know the mass of the first star is small m, and the mass of the other star is big M, and we know the distance between the stars, then the period, like the time it takes for these stars to do one whole revolution is 2 pi times square root of r cubed g n plus n, where r is the distance between the stars, g is the gravitational constant, these are the masses, and pi is pi, okay? If you plug in this in meters, this in kilograms, and g what is in SI units, you will get time in seconds. Good luck!